Hey guys, let's look at week 5 homework with dividing skills. It's a little bit easier, faster homework. We should be able to take our time on it and really get a good score. Do it a couple attempts. Okay, first one, evaluate each expression below. So we're dividing by 0 or into 0. So it's division involving 0. Let's think about it in terms of cookies. You have 0 cookies to give 6 people. 0 divided by 6, that's 0. Nobody gets a cookie. Now you have 7 cookies to give 0 people. How many cookies does each person get? You don't have any people. It doesn't make sense. 7 divided by 0, 7 over 0, does not make sense. So that's undefined. We can't define that. All right, see the difference? Okay, number 2. Which numbers are divisible by 10? So our 10s, 10, 20, 30, 40, they all end with a 0 in the ones place. Which numbers are divisible by 2? Well, if it ends with an even, if it ends with a 2, 4, 6, 8, or 0, except for the number 0, it's divisible by 2. Which numbers are divisible by 5? Well, 5, 10, 15, 20, they have to end with a 5 or 0. So all I need to do is look at the last digit. It's a 6. That's not divisible by 10. It is divisible by 2. That's not divisible by 5 because it doesn't end with a 5 or 0. This one ends with a 5. That's not divisible by 10. That's not even, so it's not divisible by 2. It does end with a 5, so it's divisible by 5. 210 ends with a 0, so that's divisible by 10. That's also even, so it's divisible by 2. It ends with a 0. It's also divisible by 5. All right, so for that one, just look at the last digit. For the rule for all 3 of those. The ones digit. Question 3, now which are divisible by 3 and 9? Okay, so to be divisible by 3 or 9, we take the sum of all the digits. 9 plus 9 plus 0 is 18. 8 plus 6 plus 4 is 18. 3 plus 3 plus 0 is 9. No, it's not. 6. Sorry. Okay, so which are divisible by 3? Well, is 18 divisible by 3? Yeah. Is 18 divisible by 3? Yeah. Is 6 divisible by 3? Yeah. Is 9 divisible by 18? Yeah. 9 divisible by 18? Yeah. 9 divisible by 6? No. So there's your answer. You do not have to work it out like this. We have a shortcut. That would not be divisible. It would have a remainder. Okay, question 4. Write all the factors of 33. Use commas to separate them. Okay, the way I like to do it, set it up like this. We're going to do times 1, times 2, times 3. Well, we can see right away it's odd, so we can just do the odd numbers. We don't have to do any of the even numbers. And we're going to go until we have a double or we have a repeat. I'll stick them in there just so we can see. So we know it's not going to be any of those. 1 times 33, 2 times nothing. It's odd. 3 times 11, 5 times nothing, 7 times nothing. I still don't have a repeat or double, so I got to keep going. 8 can't be. 9, no. 10 can't be because it's even. 11 times 3. Oh, we got a repeat. So we're done. Can't be that. So it's 1, 3, 11, 33. Those are my factors. Okay, we'll do the same thing for the next one. Factors of 21. I'll give you another example of this. 1 times 21, 2 times nothing because it's odd. 3 times 7, 4 times nothing. 5 times nothing. 6 times odd, so it can't be that. 7 times 3. There we have a repeat. So there they are. 1, 3, 7, 21. Just go right around the loop like that. Put a check by all the prime numbers. Prime, P-R-I-M-E. The only factors are 1 and me. So we know the even ones are not prime, so it can't be that. Okay, the rest are odd, except for 2. Well, only factors of 2 are 1 and 2. 1 times 2, that's prime. 1 times 5 is the only one there, that's prime. 9 has 3 times 3, so that's composite. 19, think through them. Nope, that's prime. 21 has 3 times 7, so that's composite. So there's your answer, those 3. Okay, I'll keep going. Another one just like that. Our prime numbers for this next one, the only even number that's prime is 2. 3 times 1 is the only one there. 7 times 1 is the only one there. Oh, it's even, can't be. 19, we already said it was prime. That's 5 times 5, so not that one. Okay, right, 99 is a product of prime factors. We're going to use our prime factorization tree here. So we're going to start with 99. We're going to break it up into 2 numbers. I know 9 times 11 will work. Okay, 11's prime, so we can't break that down anymore. 9's composite, we can break it down into 3 and 3. So there's your answer. 3 times 3 times 11. Those are all prime factors. 3 times 3 is 9 times 11. Doesn't matter which order you write it in. You could also write it like this if you're really good. 3 squared times 11. All right, let's do another prime factorization tree for the next one. Nope, that's the only one we're doing. Greatest common factors of 18 and 42. So I need all the factors of 18 and 42, and we'll see what's the greatest. 18, 1 times 18, 2 times 9, 3 times 6, 4 times nothing, 5 times nothing, 6 times 3. There's my repeat. So those are my factors of 18. 1, 2, 3, 6, 9, 18. Same thing with my factors of 42. 1 times 42, 2 times 21, 3 times 14, 4 times nothing, 5 times nothing, 6 times 7, 7 times 6, there's a repeat, so I'm done. So going around the horn, 1, 2, 3, 6, 7, 14, 21, 42. We're looking for my greatest one in common. Looks like it's 6. Greatest common factor is 6. Okay, don't get that confused with least common multiple. Least common multiple would be a pretty big number. We'd be multiplying. Multiples get big, factors are smaller. Okay, find the greatest common factor of 4, 28, and 12. Well, I'm going to do a little shortcut here. 4 is a factor of 12, so I know right now the greatest common factor of 4 is going to be 4, right? Because 4 is going to be one of these, and you can't have a number bigger than 4. Well, look, 28 has 4 as a factor too. So there's your answer, 4. Because it can't be a number bigger than 4, because that's all the factors of 4 have to be 4 or less. So there we have it. All right, that's your homework this week. Do your best.